Electronic Control and Digital Electronics Level 4. Module 3, Session 3.1. In this session, we will be discussing silicon-controlled rectifiers and triacs, which fall under Subject Outcome 2.5 of the Level 4 curriculum. SCRs, diacs, triacs, and quadracs belong to a family of electronic components called thyristors. A thyristor is a multi-layer semiconductor device, much like a transistor. They are mostly used in the switching of heavy electrical loads. To understand how thyristors work, let's look in more detail at the most commonly used thyristor, the silicon-controlled rectifier. An SCR is a 3-junction PN-PN semiconductor device. It has 3 pins: the anode, which is the positive terminal, the cathode, which is the negative terminal, and the gate. An SCR can be regarded as 2 interconnected transistors, one NPN and the other PNP. The collector of each transistor is connected to the base of the other transistor. An SCR requires a gate signal to turn it on, and once it is on, it behaves in the same way as a rectifier diode. SCRs can be latched on by just a single positive pulse or small positive voltage applied to their gate terminal. Unlike a transistor, once an SCR has been triggered, it will remain in the on state indefinitely. Even removing the positive potential at the gate will have no effect on the SCR. A special process called commutation must be used to attain switch-off status. The SCR can only operate with the positive half cycle of a sine wave. SCRs are high-speed switches that can be used to replace electromechanical relays in many circuits, as they have no moving parts, no contact arcing, and do not suffer from corrosion or dirt. There are many applications where SCRs are used in electronics. Some of the most common areas are as follows: speed control of motors, phase control, pulse circuits, power supplies, overvoltage protection, battery chargers, lamp dimmers, and temperature controllers. Now that we understand how SCRs work, let's discuss another type of thyristor called a triac. Triacs behave just like 2 conventional SCRs connected together in inverse parallel or back-to-back with respect to each other. Because of this arrangement, the 2 SCRs share a common gate terminal, all within a single 3-terminal package. A triac is a high-speed solid-state device that can switch and control AC power in both directions of a sinusoidal waveform, unlike the SCR, which only operates with the positive half cycle of a sine wave. Since a triac conducts in both directions of a sinusoidal waveform, the concept of an anode terminal and a cathode terminal used to identify the main power terminals of a SCR are replaced with MT1 for main terminal 1, MT2 for main terminal 2, the gate terminal G. In most AC switching applications, the triac gate terminal is associated with the MT1 terminal, similar to the gate-cathode relationship of the SCR or the base-emitter relationship of the bipolar transistor. The triac is the most commonly used semiconductor device for switching and power control of AC systems. This is because the triac can be switched on by either a positive or negative gate pulse, regardless of the polarity of the AC supply at that time. This makes the triac an ideal component to control a lamp, drill speed, or almost any AC motor load with a very basic switching circuit. Here is a circuit diagram of the basic triac control used in a lamp dimmer circuit. Let's now look at a summary of the differences between SCRs and triacs. SCRs are available with high current ratings. Triacs are available with lower current ratings than SCRs. SCRs conduct current in the forward direction only. Triacs conduct current in the forward and reverse directions. SCRs are triggered by a positive pulse applied at the gate terminal. Triacs are triggered by a pulse of either positive or negative polarity applied at the gate terminal. SCRs are faster in operation and can therefore be used to switch AC supply frequencies up to a few kilohertz. The use of triacs is limited to AC supply frequencies up to 400 Hz. We are now going to watch a video on how a triac is used in a lamp dimmer circuit.
Today we want to have a look at a component called a triac. Essentially, a triac is comprised of two SCRs joined together back to back. Very much like the silicon controlled rectifier has two transistors internally joined back to back, one NPN, one PNP. Here we have two SCRs joined together back to back. The triac is a very useful component that is used primarily for phase control with regard to AC circuitry. It is used in industry for motor speed control. It is used in industry for conveyor belt speed control. It is used for drill speed control. And if you are still using the old incandescent lamp like this one, which is on its way out, you can use it as a lamp dimmer. In fact, you can use it for any AC application where you wish to vary the AC potential to the load. So we are now going to demonstrate how the circuit works by using an incandescent lamp, and you'll see how the potential at the light bulb changes like so. So if you had a motor where the lamp is, you'd alter the speed of that motor accordingly. So the triac is a very useful component. In fact, it is used for all AC drives in industry. A very, very popular component. There are hardly any heat losses, unlike in days gone by where we used to use wire-wound potentiometers to do the same thing. Lots of heat energy losses via the potentiometer. In this case, we are using a normal carbon potentiometer. As you can see, I'm turning with my left hand. You can vary the load to any AC component by just turning this potentiometer in the direction as you can see that I'm doing. The components required for the circuit are very simple. You just need a capacitor which is connected to a diac. By the way, a diac must be used to trigger the gate. The triac also has a gate very much like the SCR. The gate is very, very sensitive, so we need something to keep the sensitivity at bay. We normally use a diac which has a breakover voltage of about 40 volts, and that triggers the action of the triac. So in this experiment, in this project, we have used the triac to demonstrate phase control. You can also use it for something called cycle control, and you can also use it for a phenomenon called cyclotronic control. So that is how a triac works. Please be very, very careful when you are working with the circuit because it's connected directly to mains. All the components have a mains potential to them, and therefore you should always make sure you have a plastic knob like this one here. Do not touch any metal parts because it could be dangerous. It's connected, as you can see, directly to your mains. There is no battery or anything here. There's no isolation transformer or anything of that sort. So care must be exercised when you are working with a circuit of this nature. So this is a demonstration of how a triac is used for phase control.
We will now do a practical in which we will build a lamp dimmer circuit on a breadboard using a triac. Your facilitator will hand out the necessary components. Please refer to your workbook for the instructions. End of the video. We'll be right back.